Okay. Hello. Chapter 317 test review. I'll start with the multiple choice. Okay, first question was if Q is negative 65 kilojoules, then the process is, and the answer was exothermic, and you could tell it's exothermic because a negative value for Q means exothermic, a positive means endothermic. In the second problem, they give you a system where they say 15.6 joules of heat is released. That means exothermic, so I can eliminate answers C and D. And then work done on it. So that means that the system is contracting. Work done by the system is expansion. Work done on the system is contraction. Question number 3. They give you an energy diagram and they say, all right, which statement is correct? And I eliminated A, endothermic, because to go from endothermic, you start with low energy reactants, high energy products. So that's out. Delta H positive means endothermic. This is not. And C is eliminated. Energy would be written as a reactant. We have to go all the way back to October and November when we said that when you're writing an equation, if energy is added, you put it on the reactant side. If energy is produced, you put it on the product side. So that's out. So this is an exothermic reaction, which means the answer is D. Energy is being transferred to the surroundings. All right, number 4, which is true. Water in a calorimeter becomes warmer when an endothermic reaction occurs. Remember, it's not what's happening to the water, it's what's happening with the reaction. If the reaction is releasing heat, the water should get if it's hotter, but this is endothermic, which means the reaction is absorbing the heat from the water, so the water gets colder. So 1 is out, so answer A and C is eliminated. 2 and 3 are correct. Exothermic reactions have a negative delta H, and heat is evolved when there's an exothermic reaction. So the answer is D. And number 5, which is true for both endo and exo. Endothermic has a positive delta H, not a negative. So A is eliminated. Energy is exchanged. Well, that's always true for any reaction. So we can select that, and then we really didn't have to read further. But, you should always read the rest of the answers because sometimes it's a matter of choosing the best answer. Energy of the products is higher than the reactants. That would be endothermic. And answer D is eliminated because delta H positive means endothermic, but that does not include exothermic. The units for latent heat, you memorize. The mass is in grams. And the unit for the constant, that's really what they're asking you for here, is the constant. And in order for that to come out to be joules overall, then the mass has to be in grams, and the latent heat value has to be in joules per gram. So I'm sorry, that's not answer C, that's answer D. Joules per gram. All right, number 7. Considering the following specific heats. All right, 100 gram sample of each metal at 95 degrees added to 100 milliliters of water. Which element will increase the temperature of the water the most? The one that required the most energy to raise its temperature to 95 degrees C is going to be the one that transfers that energy to the water, making the water hotter. So you have to pick the one with the highest specific heat, which is chromium. Answer 8 was extra credit, so I'm not going to go over it. It was a Hess's Law problem. Number 9. They give you a reaction coordinate and they say, well, what would represent the activation energy? So point B is the activated complex, and the amount of energy added to the reactants to reach the activated complex is E sub A. And delta E sub A, delta anything means final minus initial, so it's going to be B is your final, A is your initial. So the answer is B. Number 10, another reaction coordinate, but this time they want delta H. So delta H is the heat energy level of the products versus the reactants, and you do final minus initial. So it's products minus reactants, which makes it C minus A. And number 11, considering the following reaction profile, again, another reaction coordinate, and they want to know which of the following pathways would represent the formation of the activated complex. So going from A to B would be the activated complex. Answer B. And for number 12, which of the following statements is true? So you have to recognize that if delta H is negative, then that's an exothermic reaction. So it's not going to involve work energy because exo and endothermic involves heat. So answer A is out. The activation energy has nothing to do with the overall delta H, so that's out. Heat added to the system is endothermic, so that's out. So the answer must be D. Number 11, or 13 rather, was again extra credit, Hess's law. But really it should have been, it's not Hess's law, I'm sorry, it's a Chem, but you really should have gotten it because they're asking you, I'm sorry, this one was not extra credit because the delta H value was negative 286, so they just wanted to see if you knew the definition of an endothermic reaction. Number 14 was extra credit and difficult Hess's law problem. Number 15, same thing. It was extra credit because it was a Hess's law problem. Okay, number 16, system is in equilibria. Now, a hot object and a cold object meet at the interface. That's a true statement, but it doesn't describe what's happening at equilibria. The speed of the hot particles translate energy to the cold particles. Again, that's true, but that's not position of equilibria. So C is the correct answer. Two objects have been in contact long enough so that the average speed of all particles is now equal between the two objects. That's thermoequilibria. Again, none of the statements were wrong. It's just that C is the best answer because it actually describes the equilibria condition of it. And number 7 is just the definition of specific. Number 17 is the definition of specific heat. And number 18 is the units for specific heat. Number 19, the difference between the energy of the products and the energy of the reactants is delta H. And really, you should have eliminated answer A and B because we haven't studied those two aspects of thermodynamics, so delta S and delta G should have made no sense to you. And that's just a matter of, is that heat or is that change in heat? And obviously, if you're going from one thing to another, it's a change. Activation energy is the amount of energy required to bring the reactants together, right time, right place, correct energy on the functional group with enough energy to break bonds, and that's called an activated complex. Okay, the FRQs. We'll start with the conversion problems first. And I'm not going to belabor the conversion problems because most people did a pretty good job on this, but I will tell you the things that people ran into problems with. This kilojoules versus joules thing, and kilocalories versus calories, calories versus dietary versus regular calorie. Again, the larger entity, kilo, gets the value 1. So if you look at all of these, 1 kilojoule, 1,000 joules. This fraction right here, 1 calorie, 1,000 calories versus 1 kilocalorie. The larger entity always gets the value of 1. So again, it was just a matter in terms of documentation in sig figs is to go through, start with what they give you, multiply by a fraction, cancel out your units, and get your final answer, which most people did very well. In the third question on the test, again, you can go back. You're going to have to keep scrolling back and stopping the video in order to see the questions. But in the second section, rather, how much energy is required to raise a certain amount of mass of water, certain temperature range, and they give you a specific heat of water, so you're just substituting in on question number 1 into Q equals M delta TC. For question 2, they give you the energy, the temperatures to get delta T, and the fact that it's they give you the mass. So you can solve for Q equals M delta TC to get C, which is specific heat. And some people lost some documentation points on that. Again, formula first. And when I say algebra documentation, it means you have to solve for the variable before substituting in the numbers. So the answer looks like... That's making me nauseous. There you go. Q equals M delta TC, and then I substitute it in 3 sig figs. And then, again, documentation. Q is M delta TC, and then you solve for the variable. Then you substitute in your values. For the last problem, they were saying let's take 122.60 grams of water and let's change its temperature from negative 76.2 degrees Celsius to 367 degrees Celsius. So it goes through all 5 processes. Q1, you're adding heat to the liquid, or to the solid rather. W2, you are melting the solid. Q3, you're adding heat to the liquid. W4, you are boiling the liquid. And then in step 5, even though I think I wrote 4 here on my answer key, step 5, you are changing the temperature of the steam. Make sure you use the correct specific heats and the correct latent heat values for each step. And then you had to add them up at the end. So you needed an equation. A lot of people didn't do the equation, which would have been Q total plus W total. And if you were within 1 sig fig, I gave you full credit because it's hard to do the sig figs on this problem. And then the essay was make a chart and describe what's going on in all 5 sections of the heating and cooling curve. So this was your heating and cooling curve right here. And each section had to include the phase. So part A, it's solid. Part B, solid to liquid. Part C, liquid. Part D, liquid to solid. Part E, gas. I wrote liquid to solid. Oh my gosh. Liquid to gas when you boil. Sorry about that. And anytime you change phase, it was work equals mass times the latent heat. And anytime you change temperature, it was Q equals M delta TC. And then to get the freezing point and melting point, you just follow that over to the chart here, which was about negative 67 degrees C. And for the boiling point and condensation, you do the same thing. And it winds up being negative 20 degrees C. Okay, in the last problem, well, I should show you the problem first, but it's a pain. Hey, okay, here it is. My handwritten problem. 40 grams of cold water at a certain temperature is added to 94.7 grams of hot water at a certain temperature. What's the equilibrium temperature of the mix? And this was a Q gained equals negative Q loss problem. So again, Q gained, the solid gained the temperature. So it was M delta TC, so MS means mass of the solid. T, that would be the final temperature of the solid, minus TI, which would be the initial temperature of the solid, times the specific heat of the solid. And then on the other side, we do, wow, I wrote solid, I'm sorry, cold liquid. Let's change this to all C's. Sorry, the mass of the cold liquid, temperatures of the cold liquid, specific heat of the cold liquid. And then on the other side, we're talking about the hot liquid, so I'll do H for hot. So both sides are just Q equals M delta TC. Set them equal to each other, and then solve for X. All right. Hopefully that helps prepare you for a retest if you're taking it. And try to get as high of a grade here in the 3rd marking period as you can, because if you're one of those unfortunate people with a 92 average, you cannot bring it up to a 93. Anyway, thank you.